Hello, everybody. Thanks for joining today, and thank you for attending the meetup. Hope everyone is doing good and staying safe. Take care of yourself during this COVID situation. I know these are tough times, but thank you for joining. So today we have Bob with us. Bob will be going over JavaScript asynchronous events, and he will be giving some insights on asynchronous coding with JavaScript. So with that said, if you are attending our meetup for the first time, feel free to introduce yourself. And you can also subscribe to our mailing list to get future updates. So I think, Bob, you can go ahead and get started.
Okay. And based on what I heard, you guys picked an awesome talk, I think, to come and listen to. I will point out, as I said a little bit earlier, I have a 6-week-old at home, and she's rather unhappy at the moment. So if you hear screaming in the background, that's not me in JavaScript. That's my daughter. Hopefully we won't hear too much of that, but her bedroom is directly above us, so I'm hearing the floor creak every once in a while, so I'll try and keep that to a minimum. My name's Bob Fornal. I'm with Leading EDJE out of Dublin, Ohio. Let's see, I've been writing code professionally for the last 7 years. Prior to that, for 25 years, I taught computers. I kind of did this backwards from a few folks in the industry that I know that spent 25 years writing code and then went off to teach at various colleges and that kind of thing. In this process of coming back into development, I wound up in front end and essentially self-taught myself as I went through there, and there were some oddities I was seeing in synchronous asynchronous activity, which is where this talk came from. And what you'll see in this talk is probably as close as I'm ever going to allow myself to get to doing live coding. In fact, I've given the talk before, and there's one slide, we'll keep our fingers crossed, that should have a particular error come up. And I've had, when I tested it at home, I probably tested it 100 times, never errored. First time I did it in front of a crowd, it didn't work right. So we'll keep our fingers crossed that that works right tonight and see how it goes. Can I get a raised hand from a couple of folks to see if you can see the initial slide here? I can see that it's highlighted with a green border on mine. Ah, cool. Hey, look, raise hands works. Awesome, guys. Thank you. That is the difficulty in giving this kind of an online virtual talk, is getting feedback. So I may ask for that or some comments in the chat. We'll see how it goes here. But what we're talking about here is the asynchronous nature of JavaScript. And if you haven't had the argument with someone before, you're not too deep into JavaScript yet, which is, I've been in the argument many times with folks telling me that JavaScript can handle multiple tasks at one time. It's doing multiple things at a time, and it's not. It's single threaded. Okay, only one action occurs. When JavaScript's running a particular line of code, there's nothing else that can occur. Now, there are things that occur, and that's what this talk is, the core of this talk is about, that allow that, allow it to seem like it's more interactive, more, it has the ability to be more asynchronous than it truly does. And a lot of that comes down to the browser itself and the APIs and that kind of thing. That's where we're going to dig in a little deep here. So we'll be looking at the boundaries of asynchronicity as it applies to the browsers. We're going to be taking a look at user interactions, network interactions, disk processes, inter-process communications timers, and those kind of things. So let me move on to the next one here, and let's just do a couple of quick definitions. So we're taking a look at parallelism, multi-threaded processes, and scheduling, things that occur at the same time. And then asynchronous, what we're talking about with JavaScript is it has an asynchronous nature. It's single-threaded, but it has what's called an event loop. And we will get into that in some detail. This is managed by concurrency and contention. So concurrency, higher level tasks that occur within the same time frame. Okay, that doesn't necessarily mean that JavaScript is handling those tasks at that point in time. And then contention, multiple things that need to occur at the same time. If you've ever seen JavaScript bogged down, that's typically what's happening is you have multiple events that need to occur around the same time. And JavaScript truly, as a single threaded process, can only handle things so fast. And we will actually look into some of the speed of some of these events as well. So, engine details. These areas were probably where I started doing my initial investigation. So I was looking at setTimeout, the event loops, the web APIs, the messaging queue, the task queue. And the biggest one that got me the first time I really dug in and researched it was setTimeout is not a part of JavaScript. setTimeout is an API that JavaScript can access. Okay. And we'll look into some detail on exactly what it does, but at its core, really, setTimeout is basically saying, I want to fire some event at a future time. And you essentially tell it in milliseconds how far in the future you want that event to fire. And if JavaScript can do it at that time, it will. It's not quite as simple as that, but we'll get into some details. I'm jumping ahead of myself. So I'm going to pull this quick description up, a quick image up, essentially, where on the left side you'll see a heap and a stack. And I'm assuming some basic fundamentals of programming, but in the heap and a stack type of setup, you maintain your objects, your variables, your functions, and things like that, and things occur in that single thread. The web APIs, Ajax, the DOM, as I said earlier, the setTimeout occur outside of that JavaScript runtime. And then events get pushed back in through the callback queue, so that as JavaScript has the ability to run something else, it goes to the event loop to the queue and says, hey, do you have something else that I can do? Okay. So that's kind of how that all pulls together. And my mouse disappeared on me. There we go. And so we'll get into that in a little further. That image, if you search for JavaScript event loop, you'll find that there are probably 100 different versions of it out on the internet. Easy enough to track down and find. So Callback Hell is another piece that we hear within JavaScript when you're talking about promises. Okay, and promises are another piece of this asynchronous nature that developers have to work with. The pyramid of doom, the inversion of control. So we're handing off control. We don't know if that event is ever even going to come back correctly. We can't reason about what that's going to do outside of JavaScript's control. And some of the considerations, you can see the list down there. Nothing too big a deal. That trust point and inversion control is one of the big ones that we have trouble with promises and that control inversion. Okay. So moving on through that, let's take a look at what we're going to go to in some of these Callback Hell exercises. We're going to be going through a simple thought exercise at the beginning. It's a really easy one. This is going to kind of show how I'm going to present the code to you. It's not so much what that initial exercise is, as much as getting you to see how I'm going to present this as we move forward. After that thought exercise, we'll be looking at some synchronous code, some non-asynchronous code, which there is a variant there. We'll be looking at some simple network code, some complex network code. We'll be looking into some of the ES25 promise code, simple and complex. And yes, I had to break this up onto 2 slides because I couldn't fit it well. We'll be looking into generator throttling. We'll be looking into user interaction, event listeners, web workers. We'll be looking at timing code, looking at race conditions. And that's the one that I'm hoping this loaded right. Like I said, the one previous time I presented this talk, it didn't work right, and I had to refresh find the slide again and did see it correctly run. And we'll be digging into some depth actually on the set timeout timer and looking at the ES2017 async await. Now, before I jump into the thought exercise, a couple of the folks that had come in that had made some comments early on in the chat introducing themselves, it said that they were looking at either exploring or coming back to JavaScript. One of the things that I'll say with this talk is that it reaches all levels. If you're experienced, you're going to get something out of this. If you haven't written a line of code, you're probably going to get something out of this. I've had folks all ranges, non-developers on that get a little better understanding of what JavaScript is actually trying to do when it handles these events. And I mean, we're talking really simple events. We're talking things like going out to API, getting data, right down to handling a mouse click and detecting that it's at a particular location on a page. Okay. So jumping into our thought exercise. And let me show the code that we're going to use with the thought exercise. Okay, so this is the basic style that we're going to do here. So we're going to have code on that right side, and kind of get a couple hands up that right side, the console is large enough for everybody to read. I can actually make it larger if I need to. All right, if anybody really needs it larger, throw something in the chat. I'll keep an eye on that for the next few seconds to see if I do need to raise that up. Now, what you'll see is most of these functions are 3 or 4 lines long, no longer than that. There are cases in the code as I move forward here where you'll see that I went through some real heavy manipulations to get them to 4 lines of code or less. Reasoning being really simple. I wanted to be able to present the code in a simple way. So I opted to use the console because this is a place I can execute that code really easily, and we can see the results very quickly. The problem is console, after 5 lines of code, abbreviates. We get a 3-dot ellipse and we can't see the remainder of the code. So I cheated, shoved it down in and forced it down in a couple of places. You'll see later on where it gets there. But here you can see up at the top, we declared a time variable, setting it to 10,000. In this case, it's milliseconds. We have a change color function. We have a change layout function. We have a wait. We have an event. And with almost all of these code samples that you'll see me running you through, there's a start somewhere in there. Okay, so that's usually the first one we're going to look at. So looking at this, we want to, what I'm trying to get you to do is think about what you think this will do. Okay, if you look at the start, we're grabbing the button. Okay, so get element by ID, the thought button. We're unhiding it, so I'm going to bring that button up. And then you'll see that there's an event that actually gets tied to the button. That event changes the color, changes the layout, executes a wait function. Okay, pretty straightforward. So usually when I'm executing this code somewhere else, I can say, hey, what do you think it's going to do? Okay. So here, that's a little harder to do. I mean, I suppose I could wait for the group chat, but I think that's probably the wrong way to go with this. So we really have 1 or 2 possibilities that's going to happen. Okay. In most crowds, what I get is I'll get someone in the crowd to say, hey, we're going to see the color change. We're going to see, which is the background color. We're going to see it change to red. And we're going to see some text get applied on the layout. We'll get to a paragraph tag. Okay. And then the other half of the crowd's going to say, hey, we got that wait sitting there. And my suspicion would be, looking at this as somebody sitting in a crowd watching a speaker, is something odd's going to happen because of that wait. And that's exactly what does happen here. Okay, so if I click, I get my mouse way over there on the other screen and click that, you don't see the color change. You don't see the layout change. Okay, and if I've counted right, we should be coming up on 10 seconds here pretty soon. Assuming it actually clicked, I probably need to code it to put something in the console. Where'd my mouse go? Oh, wait. Sorry, I got 2 mice here. There we go. Let's try that. There we go. 1003, 1004. Yes, I'm counting to 10. And there we go, 10 hits. We got the background color red, which is really obnoxious, and we got the thought exercise code to come up here. And then clean that up here. There we go. So we don't have that obnoxious red blaring. So what happened was JavaScript was executing that while loop within the wait continuously. Okay, the change color, the change layout would have initiated, because those are sub-functions. The way way things operate is it didn't get completed with either of those before it moved on to the next one. And it's trying to run these things to give some hint that things are operating in parallel when they're really not. Okay, that while loop, because of the way it's written, is iterating so fast that nothing else can occur till it's completed, till its 10-second timeout is done. There are ways to bypass that and fix that that we'll see, and that's actually written as badly as could be intentionally. And I did that on purpose to give us that exercise, okay? To get us started thinking about, why did these things occur this way? So the next example we have here is the non-asynchronous code. And yes, the debugging's showing. So let's take a look at our, let me clear the console, show the code. There we go. Hey, that's much easier to read. So looking at this, we have an array of numbers. We have two different for eaches. We have one that's synchronous, one that's asynchronous. Okay, we're going to take a look at how these callbacks are handled. Okay, and on the first one, you see inside the for loop, it's just firing the callback. On the second one, you'll see that it's wrapped that callback in a set timeout to give us some asynchronous behavior. Okay, we've got to run for both the async and the sync, and that's mostly because I couldn't put more than 5 lines inside these functions, or it would abbreviate. We have a start that allows it to run the asynchronous or the synchronous, and I will get to the debugger as the last piece, one of the pieces that I try and show folks. So when we run this, the expectation I usually ask here, what do you think is going to happen when we run the synchronous version? And if you look at the run sync, you're firing a console log, the start, you're running a for each sync, and inside that we're console logging. At the end of that, we console log again. Okay. So as I ask, what are things going to look like? Well, it should be, and remember, it's been about 6 months since I've done this, so it should be the start, each of the numbers multiplied by 2, so 2, 4, 6, and then the end. So if I run this non-sync, we get the start, 2, 4, 6, the end. Okay, so let's go back and clean this up and go back to our code again and take a look at the second one. We're looking at the asynchronous version where we've wrapped it in a set timeout. Now that's a 0 millisecond timeout. So there shouldn't be too much of a significant variant in that, but as we'll see, as we execute this, we get a completely different output. We get the start, then we get the end. Then because they've been executed as set timeout, they go to the event loop as JavaScript has availability, as it has computing cycles. It grabs those events, which are the ones that are fed off for the console log for the 2, the console log for the 4, the console log for the 6. Okay, hopefully pretty straightforward there. And the other piece I want to show here is the async debug. So let's see, I'm going to just clear the console here. I'm going to run this async debugged. Okay, in this case, I turned the debugger on, and I'm actually amazed how many folks that I talk to that have spent a lot of time digging into JavaScript, from the junior level to mid-level to senior level, that really aren't aware that you can just throw the word debugger in there and it's going to stop, and it's going to give you a lot of information. And one of the really nice pieces now in the debugging capacity of our browsers in fact, most browsers now, that Edge is now following along the same pattern here, is that the asynchronous nature is no longer something that has to be turned on. When I first put this talk together, I found some notes on how to turn on the asynchronous debugging, and you no longer have to do that. It's built into it from the beginning, which I think is really cool. But just kind of wanted to show you that that's out there, that you can get to that fairly easily. And it seemed like I don't know why, for me, it seemed like a good place to throw that in there. So that's what we threw in there. So moving on, non-asynchronous code, nothing too complicated there. Okay, we're using the async essentially to push it into that event loop to get it out of JavaScript's control for a short period of time. Okay, and let's move on to, am I on the right one? Simple network. Sorry, I felt like that moved funny. Yep, that was right. Okay, sorry. So, simple network. Okay, and when I say simple network, I built something that is insanely simple. Okay, we're not actually doing a network call. We're using a set timeout for a delayed amount of time to see what's going to happen. And you should be able to look at this and see pretty quickly, even if you don't have a lot of JavaScript knowledge, that since we're using a set timeout with a delay of 10 milliseconds, that we probably should see the start, the end, and then 10 seconds later, we should see asynchronous code after however many milliseconds, and that fires. So we're going to start this one up, and we see the start, we see the end, and I'm counting in my head again. Should be somewhere around, there we go. Yeah, it's a nice long delay on it. Again, just reinforcing, okay? And what's essentially occurring here is we're passing that function. In this case, we're using a shorthand fat arrow notation on a function to set timeout. That gets executed at the end of that time, okay? There are some drawbacks with set timeout. One of the biggest is you're not always sure what variables are passed in. You get some odd results. If you're, say, inside a for loop and you're trying to use the I off the for loop and you're not passing it correctly to the set timeout functionality because it has to be passed into that function. Well, this is one of the areas where fat arrow has helped us out a lot, because essentially it hangs on to the variables outside of it at the time of its instantiation. So in this case, when we pass it to set timeout, we're instantiating it, okay? So let's take a look at a complex network request and see what my version of a complex network request looks like. And this is a point where, again, I ask the crowd a question, and you can see here we do a console log of 1, we execute this dot first, we have a console log of 5, and then inside first, wrapped in a set timeout, we have 2 and 4. The time on this one is 0 milliseconds. Okay, and in between those two consoles, the 2 and the 4, we execute second, and second again wraps a set timeout to fire 3. So I would normally ask, and I invariably get somebody that says, I'm going to get 1, 2, 3, 4, 5, and then I'll get somebody that says, I'm going to get 1, 5, 2, 4, 3, and I've seen every variation, and folks asking, and I think we're going to bog down our group chat if I ask you guys to give me your thoughts on what we're going to get there. So let's just run it and see what we get. 1, 5, 2, 4, 3. Okay. And part of me, when I looked at this one, and we're coming up to that later on in some more detail on set timeout. Okay, we're going to step away from set timeout here for a little bit, look at promises and things, some other things in there. We're going to come back to set timeout. Okay, because as a developer, in the back of my head, I'm going, it's 0 milliseconds, right? It handed it off, so it should come back that fast. And there's a reason it doesn't. We will talk about that in some depth. In fact, I've got some code that shows exactly why it doesn't come back right away. Okay, but we'll come back to that here in a bit. What I want to take a look at now is promises. Let's take a look at our code here for promises. And this is a really simple promise. So if you look at the start, we got a console log start, console log end, and in between that we have this type timeout function that's fired and of this dot promise. So the timeout is, again, we've seen this, set timeout fires. We've got a console log inside that. So we should see that given the examples we've run in the past, okay, and again, I would ask the crowd, but here I'm going to just talk it through. Given the examples we've seen in the past, the set timeout probably is going to be sometime after the end. Cool. But then we got this promise in there. Promise doesn't work with set timeout. Okay, it's got to resolve and reject. And inside this promise, when we're building that promise function, that promise callback, we're expecting the promise to pass in a resolve reject function that we can use. In this case, we resolve it with resolved. So the question becomes, does that use API to go outside, or does it execute inside? So should we see the start, the console log of the resolution, which would be resolved, the end, then the set timeout fired, or should we see the start, the end, resolved, and set timeout fired? Or should set timeout fired before resolved? But let's execute it and see what happens. Give us an idea of what's going on here, okay? I'm going to talk a little bit about promises once we get, hey, look at that, resolved, fired after the end, but before the set timeout. Okay, so there's some odd handling that goes on there, okay? A couple of things with promises. Now, notice I wrote this with both resolve and reject handled, and you should. I've seen enough cases with developers that forget to put that that catch block in, that rejection, handling the rejection, or not handling the rejection, that really you absolutely should have it in there. Promises were put in place to somehow offset some of that inversion control. Okay, so the inversion control we've had previously is with a set timeout, we're giving control away. We don't know if it's ever going to complete. We don't know that it's ever going to come back. If it does, we don't know what JavaScript's doing at the time that it comes back. It could be buried in some other process and not be able to have the time to appropriately handle it. Okay. Promises were designed to start to get around that inversion control issue. Promises have a trust that they will only resolve one time. They're either going to resolve as a success or an error. Cannot be both. Okay. Messages are passed. Messages are kept. Okay. So that when we resolved with the word resolved, with the string resolved, that's passed forward to the then block. Okay. Exceptions become errors within promise chaining. And this one's a little tricky, and I'm not going to dig into it too much, but essentially the values within the promise are immutable once they're resolved. Okay, so that string, it becomes immutable at that point in time. Doesn't mean we can't use it. Doesn't mean we can't add it to another variable, manipulate that variable. But that core is immutable till once resolution has occurred. Okay. All right. So, what did it give us? It allowed us pass values. Promises are a much cleaner nested syntax than we ever had with set timeouts and that type of functionality. And we handled failure, which we didn't have in the past. Okay. So let's take a look at a complex promise. And let's see, let's take a look at, I should probably clear it first and look at our code. Makes it much easier to read. So we set time, let's go down to the start. We've learned this now. Okay, so we got a console log start, we got a this timeout, we got a promise 1 and a promise 2. We got the end. So we're gonna try and guess what's gonna happen here. My guess initially, based on what we've seen in the past, is we're gonna see the timeout fire last. Okay, so we're gonna get set timeout fired. We're gonna probably have the start, the end fire at the beginning. We had this promise 1, and if I look inside there, that looks just like the promise we had on the previous example. So I'm expecting that's going to be right after the end, but before the set timeout fired. And we have a second promise in here that does things just slightly differently. If you look inside the resolution, so it's going to resolve 2, should be after the resolve 1, but it's also going to execute that promise 3 that's going to resolve, and it's going to console log as well. Okay, so should I get resolve 1, 2, 3, then the set timeout after? I guess we're going to find out when we execute it, huh? Hey, look at that. That was a good guess on my part. Okay. I will say this is a lot more fun when in a large crowd and seeing the examples and hearing the logic behind what people are thinking. Now, next area I want to talk about here is generator throttling. And if you haven't been around JavaScript in a while, generators are relatively new to JavaScript. New enough that I have a series of posts that I put together recently on practical examples of generators. So when I first saw them, I was digging through other languages. What are other people doing with generators? And none of that stuff made sense from a front-end perspective. And I spent some time digging around in how they could be used, and in the process realized that they, from a state management perspective, was almost exactly what I needed for this presentation that I built. Okay, I built the controller that you guys aren't seeing on the back end, and then the front end with all the code using a generator. It's a fantastic state machine. Okay, not only do I handle the states, but I can handle the font sizes and that kind of things as well. So it gave me a really dynamic slide deck. And in the process, I also learned that Chrome tabs could talk to each other, which I was always taught things are sandboxed and you can't do that kind of stuff. And in the process of designing this thing, I found out that it is possible. It's not code you find on Stack Overflow easily, but it is out there. So, but generator throttling. Okay, so let's see. Oop, I'm leaving you hanging there, staring at the old code. Let's look at the new code. Okay, so generators. This is where we start talking cooperative currency versus preemptive currency, concurrency. Excuse me, wrong word. Cooperative concurrency versus preemptive concurrency. As I said earlier, state machines. Okay, this is about solving part of that reasoning about issue. This gives us the ability to reason about what's happening within the generator itself, the for loop itself, essentially. It allows us a non-run to completion behavior, okay, with localized blocking. And generators return an iterator, essentially something we can loop over. And what we've got here, so let's take a look at the code and see if we can figure out what's going on here. The generator I used for the project is completely different. This is enough to get us started and give us an idea of what the generators are going to do. Okay, so we build this throttle, and actually I'm going to skip off the start for the moment, because if you look at the start, it's not doing much. It's building THR, it's setting up a throttle, passing in console log, and 3,000 milliseconds, or essentially 3 seconds. And if you look at the throttle generator up above, it's receiving a function at a time. It's tracking a timer ID, clearing the timer ID, setting a set timeout, executing. Yeah, it gets really interesting in there with the function bind. It's binding the window, which is the root of console log, or sorry, root of JavaScript, and arg, which arg is the throttled argument passed in. And you'll see what that means here in a minute. And then time on that set timeout, so 3 seconds. So what should occur here is we've essentially built a really quick 3-second throttle. Okay, so that I can fire a command over and over and over again. So I'm gonna start my throttle. And one of the odd ones I learned was when you build that generator, for some reason you have to fire the first one before it does anything. So if you see that thr.next with an empty string, that's just initializing the generator loop on the throttle. Okay. So once we've started that, now we can repeat, and you can see I'm firing this thr.next send a comment. Now I'm going to give it a couple of seconds. 1,000, 1,000. There you go. You see the send a comment come back once. You see it come back once. I sent it in this case, 16 times. It only console logged once. Okay, in that 3-second window. Okay, so real quick, easy tool. I will be honest, as a developer, as someone that's out there writing code for front end, with the mentality that I want to write code assuming that the next person looking at my code is an axe-wielding maniac who knows my address, this probably isn't going into most of my production code, okay? I'm hoping to get a little chuckle out of you there because while generators are cool and there's lots of neat experimental kind of things we can do with it, and it does handle that reasoning about it, lets us kind of understand what's happening internally in our iterative loop a lot cleaner. It also, logic-wise, when somebody goes back and looks at it and says, what the hell are you trying to do overall, I think it becomes more complex, okay? So let's go back to something a little simpler. And we're going to go back and take a look at some user interaction. So in this case, my user interaction is a drag and drop, okay? And if you've ever written any of your own drag and drop stuff, one of the early ones that occurs is you have a console log and you say, hey, I want a console log while it's dragging. And your console log just kind of goes haywire and sends tons of useless information because there's so much of it. But this is one of those cases where some additional functionality has been added to the browser to make this a little more functional. So if we look at, we don't really have a start necessarily on this one because the code's already running. We have a drag start event, okay, up there at the top. When the drag start fires, this event gets fired off, it console logs the drag start, passing the event information, which we have a data set ID attached to it. We have a drag over, which triggers the prevent default, indicates that we're moving over something, console logs our XY position. And then we have a drop event, which passes the ID to the new element, allowing us to indicate that it's been dropped there. So if I get the correct mouse on my desk here and get over this red box and drag, you can see when it's over something, it's console logging when it's moving over, okay? And let's see if it does it on the second one. Yep, it's doing it on both of them. But if I drop, there we go, it dropped inside that one, and I can drag it, should be able to drag it down here. There we go, drop it in the other one. And we see all this really cool drop drag, and somewhere up there you see a drag start event, and we see the drag drop event, okay? And this is, again, some of that asynchronous behavior allowed because they've embedded some functionality into the browser. So as we drag, it's not purely JavaScript trying to handle that, okay? Just an interesting code example there, I think. Now, let's go back and, hey, okay, gotta click that twice there. Let's clear our code here, and oh, wait, didn't like that. There we go. So here, event listeners, okay? And I got a link out there we'll have to click on once we talk about our code. So let's see what we're doing, okay, and see how this applies and what the event listeners do and what that means to us, okay? So we've got a start we're grabbing an element by ID, the event listener link. That's the link you see out there, the blue. We have a setup event listeners. So up there, setup event listeners. There we go. It's a little bit long, but basically we're setting up 2 click events and we're binding in the output. Okay. This.output.bind. Got that. So if you look up output is a function, and I had to write it this way so it again didn't get too long. All output does is console log. Okay. But we have to tell it what to console log. And the null is in there because you have to handle this on when you bind. In this case, I didn't need a this, so we just passed in null. And we have trigger event listeners. So this is a set timeout that does a start end button click over this.time. And where did I set up this.time? Okay, we're not going to worry about that at the moment. Let's see what this.time is. I don't know where that went. That should be in there. Ooh, there we go. Nope, it's not declared yet. Okay. Well, let's not worry about that at the moment. I don't worry about the time on this, but on the event listener. So let's click it, see what we get here. Okay, so we're connecting the event listeners to that. Okay, but I gotta start it up on my side. There we go. Now it's started. Okay, so it started. We had to click handlers. We had the end event, and when we click on it, and you notice click handler 1 and 2 fire. Okay, so what does this tell us? Because the click handler 1 and 2 fired inside the start and end. Okay, where the button click fired that inside your trigger listeners. Because that fired inside there, our event listeners are synchronous. They are controlled by JavaScript, not by the browser. They're not asynchronous, which seemed odd to me because we're talking about user behavior, user events, things like that, but it is the nature of what it is. They're not asynchronous, okay? It's an odd one. There are plenty of odd ones in this whole scenario. All right, so let's go on and look at something kind of cool. Let's clear that off. There we go. And let's look at some web worker synchronous code. Okay. I would assume most of you have heard about web workers. Okay. I'm going to ask real quick how many folks we have that may have heard. Can you raise a hand real quick if you've heard about event listeners? Or sorry, web workers. Jeez. Okay, so I got a couple. About what I expected. That's pretty cool. So web worker. Web worker is an attempt to allow code to run outside the JavaScript thread. And they're really cool. They're really easy to mess up. They're not too difficult to dig into and figure out why you messed them up. I have had a few questions, and I'll answer this one right now. The number of workers from browser to browser varies. Okay, most browsers seem to be able to handle about 20. Okay, there are some browsers, I believe Firefox allows you to dynamically decide how many, but realize that you're tying into CPU cycles at that point in time. So 20 seems to be be a good place if you're going to spin up a number of web workers for some heavier processing. Okay. So what are we talking about here in terms of this web worker and what we're going to be doing? Okay. What we're looking at here in this code example, this is the synchronous code. This is a non-web worker fired. Okay. So we've got it with an ability to start async and sync. So we're going to run async. In this case, we're only looking at, because there's so much code, I'm only looking at the synchronous in this case. Okay. The non-web worker-ified, I'm going to call it. Okay, so when we run sync, we're setting an inline progress. We're setting up inline progress being the percentage bar. Okay, and then we're telling it to crunch numbers in line, and then we run through a for loop. We're setting up callback to fire, and we're setting a delay of about a second in there, and then it should update that percentage once a second for 10 seconds. Okay, and again, this is one of those points where I have folks stick their hands up and say, how many do you think this is going to work great? How many of you tried this before and watched it fail miserably? I have seen it many times on a percentage bar where as I start the sync here, you'll watch it count 0 to 100 and our percentage bar is doing absolutely nothing. It's really frustrating, especially when you hit that 10-second mark and your percentage bar completes. Now, while that's really frustrating, I would think about, to me, one of the things that occurred to me as I was watching this probably about the 1,000th time prepping, getting ready to give this kind of a presentation, one of the things that struck me is nothing happened in my percentage bar, but my console fired. Console log is an API separate from the JavaScript thread. And I'll be honest, over 7 years, it took me probably 6.5 of those to figure that out. The console log will fire even when JavaScript's kind of bound up doing about a bazillion other things all at one time, which is really kind of cool. But that's not the point of this particular one. We want to see what web workers are going to do for us, right? So let's get rid of that code. Let's look at the async code. So in this case, it starts the same. But we see this run async, okay? It's not doing much differently, except notice we have post message in there. Okay, what it's doing is it's telling an actual web worker that I have loaded up somewhere in the background there and telling it to start the count. Okay, and it has something we can then watch to show us when that count is coming back to us. Okay, there's a two-way communication that's allowed with the web worker. So our web worker is doing that little 1,000 millisecond cycle, while JavaScript here on the front end isn't impacted. So if we start this asynchronous, we should see something a little different. Okay, we're seeing the same console, but look at that percentage bar doing exactly what we expect it to do. Really kind of cool, I think. Okay, and I will say it kind of blew my mind when I realized console log was its own separate API. And no documentation on that I could find, although I'm sure it's out there somewhere. So this is the one that I told you earlier that the very first time I gave this presentation, it failed. Okay, so what do we got going on here? Okay, this is load timing. Okay, and what I've essentially done is I've set some JavaScript to run in the index.html file. Okay, and that code executes before this code has been loaded. Okay, so you see one in there where you see it expects this to change via code. Okay, and change content correctly via code. That expects this to change via code should have disappeared. Okay, that original content, that first line should have changed. It did not. Okay, and it's a timing issue. And if you've worked with JavaScript for a while, this should be one you should be very familiar with, but I wanted to put it in here to be complete. And we have to understand that there's a reason we've talked over the years of loading the JavaScript at the bottom of the body. Okay, that makes sure all the HTML elements are in place before that JavaScript starts to work on them. There's a reason we shifted it that way a number of years ago. And jQuery has handling to be able to know when everything's loaded correctly and all of that. It all comes down to how that code loads up and consistently runs correctly. Now, in this case, I did a really rough asynchronous load that essentially waits 10 seconds before it executes to change that text. Okay, the first one doesn't have a 10-second delay. It fires immediately. And because this part of the slide deck hasn't been loaded yet, it just silently errors. Okay, this is one of the few places I think JavaScript fails a little bit, in that it should give us an error that it can't find that element to make the change to. And in this case, it does nothing. There's no issue, no presentation that there is an issue, that this race condition occurred. Okay. All right. So I told you we were going to get back to setTimeout, and I've got some really cool stuff on setTimeout here. Okay. Let's take a look here and see what we've got. So when I started working with the setTimeout, when I started digging in and I started seeing some of this stuff, and I told you guys that it was, hey, it's running at 0 milliseconds. Shouldn't that run inside there? Well, there's a reason for that. There's a reason for the issues that we saw earlier, where we had like the start, the end, and it went right after, even though it was a 0 millisecond setTimeout, so it should have executed immediately. Well, that's not necessarily true. Okay. Somewhere in the documentation, and I have a link for it if somebody really wants to bug me on it somewhere, this would be one to catch up with me, and I might have to get back with you because I'm not sure where I have the link exactly buried. It's probably in one of my articles. But in the specs, setTimeout is defined to have a minimum of 4 millisecond delay. Unless there are more than, I think it's 4 of them, at which point it doesn't worry about that. After the 4th one, it doesn't worry about it. So even if you set 0, you got that 4 millisecond. Now what I have found out, and this code is kind of cool, because what I'm doing here is on the start, I'm setting up delay, I'm setting repetitions, I'm setting actual values, and I'm running a test delay. And if you look through this code and what's going on here, essentially all I'm doing is I'm executing, in this case, 1,000 times, and I'm catching the timing, figuring out how long each of those set timeouts runs and giving me an average. Okay? And you can change total repetitions. You can run this thing again. If you ever borrow my code and do this, that's fine. Feel free to increase it, but be careful, because I think the first time I ran it, I tried 100,000, and like 5 minutes later, it was still running. Okay, so I'm going to try this on with 0 milliseconds and see how close my browser is to 0 milliseconds. Now it is running 1,000 set timeouts, which doesn't take too long. But you can see the average delay here is 4.617 milliseconds. I do believe IE was running in the 14 millisecond range. Firefox was somewhere around 10, but then there's also some, ooh, and I spelled actual wrong in there. I need to fix that. Ignore that spelling mistake. But let's see, Firefox was around somewhere between 10 and 14, but it also to some degree depends on your machine and what it can handle as well. You know, if your machine's pretty heavily bogged down, this actually could be slower. I'm going to try it with a 10 millisecond delay. And like I said, be careful with higher numbers of delays and number of repetitions. You may be sitting there a long time. Okay, so in this case, we averaged at 11.27 milliseconds. So it actually was pretty close to 10 milliseconds. However, it's never going to come back at the exact time you expect it to. That's probably the biggest thing to take out of this. Set timeout has a base default delay that it should put in place, and it's going to execute when JavaScript has availability to execute it. Okay, we're running so many of these back to back. That's part of where that extra few milliseconds is going to come from. Okay. Like I said, if you do get a hold of my code, which it's out there on this presentation, be careful with the time, and I will make a note to fix the spelling of actual. All right, we're getting close to the end here. We've got async await. This is really the last one we've got, and we're actually doing pretty good on time. So let's take a look at async await and what we have in here. Okay, so async await, for those that do know, don't know. If you don't know, this is new stuff. If you do know, this is going to be a little boring, but what async await allows us to do is essentially write promises in cleaner, easier to read code. Okay, so if you look at that async await right in the middle there, where we got a try catch wrapped around it in the console log with the await, the async process, what it's doing is it's wrapping that async process in a promise. Okay, and that promise resolves or rejects just as any other promise does. Okay, so we see in our start that we're going to set resolve to resolve state, and where's resolve state? Oh, resolve state's passed in. It's a Boolean console log. We're starting, we're executing async await, and then we're ending. Okay, so async await in there is console logging, and it's executing async process. If we look at async process, it returns a new promise. It's got a set timeout wrapped in it. We got a little bit of everything in here with the rejection, resolve reject in there, and we're doing this over a 2-second window, and we have a success message that I did that way just so things were a little bit shorter and easier to see and reason about the details. Okay, so we got a success or failure that could occur. So what we should see is the start, the end, and then somewhere in there a message that we're doing something after 2 seconds. And I've actually have this set up to run both resolve and reject. So we're going to see the resolve here. Hey, 2 seconds later, resolved. If we do the same thing, passing in fail, hey, look, it rejected out. It failed after 2 milliseconds. Okay. Async await expands on our use of promises. It makes it a little easier for us to reason about, to read the code and what's going on there. We write asynchronous code that looks and feels synchronous, which is how most JavaScript developers read their code. They expect it to be synchronous. Cleans up the syntax, makes it much more readable. If you look at that async await versus the async process, to me, it's pretty clear which of those two is easier to read and reason about. Okay. So after, what do we have here? About 50 some minutes of listening to me talk. We've gone over synchronous, asynchronous code using callbacks. We've looked at using the debugger within our console. We've looked at ES 2015 promise chains. We've looked at generators as to handle throttling. And I would hope you understand that this whole presentation is a large set of generators in and of itself to handle the slide deck. We've looked at how user interactions and event listeners are somewhat asynchronous and somewhat synchronous. Event listeners being synchronous was a little bit of a surprise. They do work correctly, but they always operate in order. Web workers, we took a quick look at that. We examined the load timing and some of the issues that can occur there. We took a look at the ES 2017 async await as well. And let's see. I'm not sure why I have the Eventbrite thing up on the summary page. I'm going to figure out why that's up there. Since you guys are already here, that would not quite sure. I think I forgot to clean something up on one of my slides, so I will apologize on that. But you got my basic information there. Bob Fornal, Leading Edge, and I think now time to open up for questions. Oh, we got a couple of questions. So
Yeah, Bob.
Somebody had to drop off early. There we go.
Yeah, we had a question from Twitch, like basically what is the difference between callback and feedback?
Callback and feedback. Well, I'm not sure what they mean by feedback. I mean, a callback is essentially a function that you pass in a pointer to that function, and that gets executed internally somewhere that then returns that execution pattern back to the caller. I don't know if that answers the question or not.
Yeah, sure. If we get any follow-up question on that, I will let you know.
Okay. I may have used the wrong word somewhere in the presentation, saying feedback instead of callback, maybe. Any other questions? Comments, concerns? I did find one spelling mistake, and apparently I need to clean up the last slide.
Yep. So any other questions do we have over here? So I don't think we are having any other questions, Bob.
Okay.
Thank you for speaking to us today and going over all the asynchronous programming logics with the group.
This one's a fun talk. I love doing this one, so I'm glad you guys invited me out. This was a lot of fun.
Yep. Thank you all for joining. And if you're looking for our next events, you can always check our website. Under events page, we have a next Vue.js meetup coming up next week. I look forward to meet you guys in our next meetup. Stay safe while you are there. Practice social distancing and take care of yourself.
Yes, thanks for having me. Nice talking to everybody. I would say talking to everybody, but kind of the nature of what we're dealing with. So thanks for coming out, guys.
Yep. Thank you all.
And thanks for having me.
Yep. Thank you, Bob.
All right.